This time it's going to be James talking about serverless Swift. So get comfortable and I'll leave it to you.
Am I? Hello? Can everyone hear me? Okay, that's on, definitely. So hello, everybody. My name is James Thomas. I'm a developer advocate for IBM's cloud division, now the lead serverless advocate for IBM Cloud. And today I'm going to be talking about this, right? Serverless Swift with OpenWhisk. I'm going to talk about a new way to build and run Swift backend, Swift APIs, Swift microservices in the cloud without having to set up or manage any infrastructure to be able to do this. No having to provision virtual machines or create containers or install Linux or any of that kind of stuff. And this might sound kind of impossible, right? Server-side, serverless Swift, right? Surely if you want to run your Swift backends or Swift APIs in the cloud, you have to set up and manage the environment to be able to do this. But I'm going to show you a new approach using something we call serverless cloud platforms that allow you to do just that. And in the second half of this talk, I'm going to do some live demonstrations of showing you how to use all these platforms so you can go away and start to use them yourself. Now at this point, as well as thinking that this sounds kind of impossible, right, serverless Swift, you might also think that it sounds unnecessary. You might think, I like my servers, I like my VMs, I like my containers. Why would you want to take them away from me? Well, the reason is this, right? Servers kill your productivity. And you might not realize it yet, especially if you're new to back-end development, but trust me, it's true, right? Servers kill your productivity. And I think by the end of this talk, you're going to agree with me that servers kill your productivity. And if you're going to want to go back to work on Monday, whenever you get back there, and if you see any servers kind of hanging around, you're going to want to set them on fire and be free from what I call the tyranny of looking after infrastructure, right? I'm convinced that servers are one of the worst things that's ever happened to software developers. So why do I think this, right? Why do I think servers kill your productivity? Well, let me tell you a story, right? Imagine you've got a great new idea for a new mobile application. You're going to build this app. It's going to be really, really popular. So you do the front end in Swift because you're a Swift developer. And you know you need some back-end APIs or services. And you've heard about server-side Swift, using Swift for back-end. You think, great, I'm going to do the back-end in Swift. I'm going to finish that code, you finish a microservice, and then you're just going to deploy it, right? Need to deploy it, need to run it somewhere. So you go to your cloud provider, you click a couple of buttons, you sign up for a new account, you provision some infrastructure, you put your code on there, your back-end code, and you think this is it, right? You're ready to go. But as soon as you make that first choice to provision that infrastructure, that first VM, that first container, that first environment, what you'll suddenly realize is, especially if you're new to back-end development, you have all of these extra tasks to take care of. You have to, if you're using kind of lower-level infrastructure like VMs or servers, you have to set up and maintain those environments, put Linux on, all the dependencies and the middleware and that kind of stuff. You've got to keep it updated as new versions of the software and dependencies come out. You need to think about monitoring to make sure it's healthy in production, and security. Is your infrastructure, is it backed up? Is it encrypted? Is it secure? Is it GDPR compliant these days? And then hopefully, as your application gets popular, right, your mobile app gets popular, you're going to need to think about scaling. And for most people, scaling means more servers, more environments, more VMs, right? And after a while, as developers starting to do back-end development, it can feel like you get held hostage by your infrastructure. You want to spend time in Xcode writing Swift, you're going to spend increasing amounts of being dragged back to your cloud provider's console to kind of debug some kind of VM issue in production. This is not really what many developers, I think, really want to do. They just want to run their code in the cloud. They don't really want to have to think about their infrastructure underneath. So the question is, well, what can we do about this, right? I'm still going to need to run my code in the cloud, but anytime I go near any of these kind of server things, it kills my productivity. Well, fortunately for everyone here today, I'm going to talk about a new way to run software in the cloud without having to think about any of the infrastructure underneath, called serverless cloud platforms. Now, let me ask at this point, who's ever heard of the term serverless before, right? It's not as common. All right, wow, that's good for mobile developers. Has anyone used any of them? Okay, so about half. Got any production stuff running on serverless platforms? Okay, that's pretty good, right? That's better than maybe I expected. But this is new to you, right? You've never heard it, or you've just heard it on people talking about it incessantly on Hacker News or Twitter. You're probably like, what is this serverless thing people keep talking about? And if you go to Wikipedia, you're going to see stuff like this, right? That serverless cloud platforms, they run your code in response to events. It manages all your compute resources for you, allows you to build event-driven applications. And you might kind of stop kind of scratch your head at this point and think, this doesn't sound very new or revolutionary to me, right? What's all cloud platforms say this kind of stuff, right? What is different about serverless? But serverless is different, and it's different, I think, for a couple of main reasons. The first is that it shrinks. I think it shrinks the unit of deployment. So once you've written your code, rather than having to like wrap it in a framework, in a deployment package, inside like a container image, which you put on some kind of orchestrator on a VM and all this kind of stuff, serverless cloud platforms literally allow you to write the code, push it straight into the platform, the raw code, and then have it execute on demand to process requests as they come in. And this is where the term serverless comes from. It doesn't mean that your code's going to run on a server somewhere in the cloud, but it means from my point of view, from the developer's point of view, you don't have to think about it whatsoever. You just write on the code and push it in, and it kind of executes on demand. Another nice thing about serverless, I think, is that scaling becomes a platform's responsibility, right? What happens is your little microservice, your APIs that you push up, they get executed on demand to process requests as they come in. So suddenly if you get like 1,000 API requests in at the same time, it's the platform's responsibility to spin up multiple instances of your functions in parallel to handle all of those requests. It's not something you need to think about in terms of like, well, how big a VM do I need and how much memory and infrastructure and that kind of stuff, right? The platform just automatically scales out on demand. And as well as scaling up, another difference about serverless platforms is they also scale down, and they scale down to 0 because your code, your little backend, your serverless functions, they get executed on demand to process requests as they occur. And when they've finished processing the request, they get put back to sleep. So it means that if you have kind of idle time within your backend, none of your code is actually running. It only runs when you're doing work, when you're processing requests. And that's really, really important when we think about the pricing model for serverless. Right? The serverless, like all cloud services and APIs, it's pay as you go, right? You only pay for essentially the milliseconds that your code is running. At the end of every month, they add up all of those milliseconds and they send you a very, very small bill normally for how much your code has been running. But because your code is only running when you're doing work, if you have any idle time in your application, you have very variable traffic, and there's times like on Sunday afternoon where you don't have any traffic, you don't have to pay anything. There's no charge for idle. And this is the first time, I think, for infrastructure in the cloud where there's been no charge for idle. And this can lead to some dramatic cost savings. So if you go online and Google about service, you'll see lots of blog posts for people saying, I moved my backend to a service cloud platform and I saved 80, 90, 95% off my monthly infrastructure bill because now I'm not paying for any of that idle time. So okay, right, enough talking about serverless at a very abstract level, right? Show me the code. Let's have a look at how to actually use one of those platforms so you can go away and start to do this yourself. And the important thing is, if you want to start building a serverless application, is you need to go and choose I got too fast. You need to go and choose a serverless provider. And today, whoever your big cloud provider is, whoever you decide to sign up with, they guarantee you they have some kind of serverless offering for you to be able to play with. Even IBM, we have an offering called IBM Cloud Functions we're going to look at in a little bit. But it's important to kind of highlight here that serverless is available on pretty much any cloud platform. They all kind of work the same way. So the techniques I'm going to show you for one provider today are kind of applicable for all of them. And to give you a bit of history about where serverless kind of came from, we need to go back about almost 4 years ago now to 2014, October 2014, when Amazon launched this new kind of beta service for cloud called Lambda, and basically kicked off this whole serverless movement. They kind of launched this new whole kind of area. And then about 18 months later, start of 2016, all of the other big cloud providers looked at this and said, this is a good thing, this is new, we're going to have our own competing solutions. And IBM, Microsoft, and Google came out with their own kind of platforms around that time. And today, everyone, even Alibaba Cloud or Oracle Cloud, they all have some kind of serverless platform for you to play with. And the one we're going to be looking at today is based on an open source project called Apache OpenWhisk. So this is actually the core platform technology at the heart of IBM's commercial offering in this space, IBM Cloud Functions, that when we developed it, we actually decided to open source the whole platform and give it over to Apache, where it's going through that whole incubation process at the moment. And recently, both Red Hat and Adobe have recently come along and adopted it, so it's got a fairly big and growing open source community. But if you are like evaluating different serverless platforms to use, I think there's a couple of good reasons why OpenWhisk is really, really good for mobile developers, or kind of developers building in the cloud. And the first is that it's open source, right? So the whole platform is completely open source, which means you can like run it locally, you can deploy it yourself, or you can go and use a managed version from a cloud provider like IBM or Red Hat. And the reason IBM kind of did this is that when many of the other serverless platforms out there are kind of proprietary, kind of secret source stuff, and we think many developers building the cloud are very worried about vendor lock-in, right? Remember what happens to things like pass.com, which kind of goes away, you're stuck. So we think by open sourcing our cloud, serverless cloud platform, it gives you a bit more long-term security, that building on OpenWhisk means that it will kind of always be around. But actually, I think the most important thing for people in this room, for mobile developers, for Swift developers, is the runtime support. So with serverless cloud platforms, you don't get any access to the environment your code runs in whatsoever. You have to set up the environment that's all managed for you by the platform. So you are beholden to the platform to give you support for the languages that you want to be able to use, right? And if you look across the different serverless providers, there's some very, very common languages and some which are more provider specific. So for example, the three at the top, like Node.js, Java, and Python, I call those the big three because they're supported across pretty much every serverless platform. They all support this, especially Node. Node really is the first-class serverless language. It's the most popular language on the platforms used by developers. But then it gets kind of a bit more interesting, right? It's a bit more provider-specific. And these are some of the ones that OpenWhisk supports. And this is very out of date now. I should have updated it. There's Ruby and Go and all other kind of stuff we've added recently. But as well as things like PHP and Docker, the most interesting thing for me is that OpenWhisk has native support for Swift built in. So you can push raw, uncompiled Swift code, Swift functions straight into the platform and have them executed on demand. And it's actually the only serverless platform that has native support for Swift built in. And the reason that we did this is that I work for IBM, and IBM has been heavily involved in backing Swift since Apple open sourced it about 3 or 4 years ago now. Done things like the foundation libraries on Linux and other platforms. We work on the language. We do things like Katora, if you've heard of popular packages like that. So for us, since we're huge fans of Swift as a language, it was natural for us to add support into the products that OpenWhisk we were developing. And also it means that mobile developers can start to build backends without having to know any infrastructure stuff, which I think is a really, really good use case. So with serverless, right, when you've chosen a provider and you've chosen a language, and we're going to use Swift on OpenWhisk in this case, the next question people have is, okay, like you tell me that I just write some code, I just push it into the platform and executes it on demand when an API request comes in, but how does the platform know what to do with my code, right? If I've got some my code like Swift like this, and I push it into the platform, how does the platform know how to execute it? Well, with serverless platforms, they all kind of work the same way. All you need to do to make your Swift file or your JavaScript file or your Ruby file kind of compatible with the platform is you need to add a particular function handler to that source file, which is going to act as like the event handler. When an API request comes in or a message comes in, it's going to evaluate your code dynamically. It's going to call that function as to process those API requests. So for Swift, it's going to look like this, right? This is a Swift 3 runtime. And this is what it looked like when we originally integrated Swift. And you can see that essentially all you need is a function called main, which takes a dictionary of type string any and returns a dictionary of type string any. And then you can write your code in the middle of it. You can call other functions. You use third-party packages. And that's what the event handler looks like. And you just need a function called main. It's a very lightweight interface. And this is what it looked like initially when we added Swift 3 support into OpenWhisk sort of like 2 years ago now. But then more recently, Swift 4 was released like a year ago. And one of the great features about Swift 4 was support for the codable protocol, right? Made it much, much easier to do kind of serialization between JSON and native Swift types and vice versa. So when we looked at updating Swift to include Swift 4 support, we wanted to support codable as well. So now, as well as using that kind of slightly older approach to event handlers, this is what it looks like in Swift 4. So you still have a function called main. That's going to be your event handler. But you can now see that it can just take a codable type in that event handler, and anything that implements the codable protocol, it kind of supports. And it will do the automatic serialization, deserialization from the JSON, from the API request coming in to that type and pass that over to you, which is a much nicer way to manage kind of events coming into your serverless function. You don't have to deal with all those nasty optional null checks and things like that. And we also have support for async operations. So if you want to do async stuff, there's a callback style approach as well, and you can kind of mix and match either of those two approaches. So I think this is much, much nicer thanks to the kind of codable protocol. So when you've written some, let's say you've written some Swift code, you've added your little event handler, your function called main, which is going to act as your event handler, you push it into the platform's going to create what we call an action. So an action is just a name we use in OpenWhisk for serverless function. So when you hear me say serverless function, think action, and when I hear me say action, think serverless function. It's just a name they've decided to use. So let's do this now. Let me take some Swift code from my laptop and quickly run it on one of those platforms in the cloud and show you how easy that is to do without setting up or managing any of those kind of VMs and containers and that kind of stuff. So let me mirror my screen. There we go. Okay, you can all see that. So as I said, right, OpenWhisk is completely open source. It's an Apache project, and it's going through the incubation process at the moment to graduate, hopefully by the end of the year. And if you want to play around with it locally, you can. It's really easy to do. You can do it with Docker Compose or Kubernetes or Vagrant. There's loads of different deployment options. You can deploy it to other kind of cloud providers and Kube and stuff like that. But I think for most people, the point of using serverless is to use a managed service from a cloud provider. And IBM has an offering in our cloud called IBM Cloud Functions, which is just a managed version of that open source project, right? Just a managed version of the open source project in the public cloud. You can just, as an advocate, say you can sign up and use, free account, no credit card needed if you want to play around. And that's the instance I'm going to be using today, but it's just the open source OpenWhisk platform. So you could try this locally or deploy it yourself, like it's all that kind of standard open source interface, which is very nice. And whichever OpenWhisk platform or instance you decide to use, you need to work some way to get code from your laptop over to the cloud platform. And so there's just a little CLI that you can download and install that comes with the open source project that allows you to do this. So let's have a look. Right, I already have all the development tools installed because I use this pretty much every day. So let's just go through. This is going to be Hello World example to show you how quick it is to get started. If I go to my console, hopefully you can see that. And I have a kind of, let's do the Hello World example, right? Hello.swift. So I have this like 5 lines, 6 lines of Swift code that you can see like implements the interface that OpenWhisk expects, right? So it's got a function called main, takes a dictionary, returns a dictionary, and it's just going to do a kind of Hello World service, right? It's going to say hello stranger or hello James or hello Sally, depending on the parameters it gets called with. So let's try it out. So using the CLI, I can say whisk action create. I give it a name, call it hello. I give it a path to the code because it's going to push the code directly into the platform. And then I can check it's been registered in my workspace. So you can see this is now the little cloud functional action that's running on the cloud or ready to execute on the cloud. And it's detected it's using the Swift 3.1 runtime, which is correct. So now I can just invoke it using the command line to test out. I can say action invoke hello. And it should just say hello stranger, right? Because I'm giving it no parameters, right? So it says a greeting hello stranger, which is the JSON result of that code executing. And I can say like name James, should say hello James, or I can say like hello Sally. And it just works, right? Somewhere in the cloud, right? This code, your Swift code has been, executing on a VM and a container and all that kind of stuff. But I don't have to worry about that. Just write some code and deploy it and execute it on demand. And I could call this function now like 1,000 times, even 10,000 times, right, in parallel, and it would just work. I don't need to worry about load balancers and rate limiting and all of that kind of stuff. I can just execute it and pay for it, and I don't have to think about it anymore. Now, this is the Hello World example, just to kind of show you the development workflow. Let's think of a slightly more realistic example that you might actually want to use, right? Maybe you're building a mobile app for retail, right? So you can buy stuff through the mobile app. And your client comes to you one day with the brilliant idea they want to integrate Bitcoin into your application. They want people to be able to pay with Bitcoin and view products because they think this is a big customer problem, right? That people can't pay with Bitcoin. So you go, okay, that's fine. And one of the problems is that Bitcoin as a currency is very volatile, right? So it changes minute to minute almost. So you can't just embed static Bitcoin prices for your products in the database because it'll be out of date very quickly. So you think a way around this is to build yourself a little API endpoint that can do real-time conversion from one currency, from krona or from pounds or from sterling, into the equivalent amount of Bitcoin in real time. And you can use that during the checkout process. You think this is a good use case for serverless because you only want that code running, you only pay for it when you're actually doing checkouts and things like that. So I actually have some Swift codes, a bit more realistic, to implement this little API in the backend. And we'll kind of quickly walk through it, and then kind of get it deployed and get it working. So you can see this is a bit more realistic, right? Maybe we've got like 30, 40 lines of pretty terrible Swift code. But you can see how it works, right? It's still the same kind of approach, right? I have a function called main, which is the event handler, takes a dictionary, returns a dictionary on the Swift 3.1 runtime. You can see it's looking for 2 parameters, right? So we need a currency and an amount from the event coming in to process to turn into the amount of Bitcoin. Then it calls this function, which goes and does a HTTP request over to CoinDesk. So CoinDesk is a Bitcoin wallet service, very popular, and they have an API, JSON API, for getting real-time Bitcoin prices, which is very nice. So we go, make that API request, we do some parsing of the JSON that comes back, and then finally we do a bit of maths down the bottom to get out the currency rate and then convert it into equivalent about a Bitcoin, and then return that dictionary to the user, which can be serialized back out to JSON. So since I've already written the codes, I can just say, okay, IBM Cloud Whisk action create. We'll call it Bitcoin and give it the path to the file, conversion.swift. And then I can test it out. So I can say, okay, invoke Bitcoin. And I need to give it some parameters. I need to give it an amount. Let's do 10,000 currency, just do dollars. And so what should happen is it should run the code, talk to that API, retrieve the amount of Bitcoin, and then tell me that 10,000 US dollars is like 1.57 Bitcoins, right? And I could try it with euros and pounds, because I don't know the code for krona. And it just works, right? You know, I've got a real little API running in Swift in the cloud to be able to do my real Bitcoin conversion. So cool, that was pretty quick, that was pretty fast, right? No servers, no VMs, none of that kind of stuff in sight. But the next question you'll have is, okay, once you've got your little functions deployed and tested using the command line, how can you integrate them into your mobile app, right? You're not going to invoke them from your mobile app using the CLI or the UI or something like that. And OpenWhisk has a couple of different ways to allow you to programmatically invoke those serverless functions. The first is through something we call the platform API. So the OpenWhisk platform has a well-documented, just RESTful HTTP interface that you can talk to from any kind of application, right? Any application, you can send an authenticated HTTP post over SSL to that platform. You can kind of programmatically invoke your functions and get the results back. And when I'm using the command line, when I type whisk action create, whisk action invoke, all that command line does is basically talk to the platform API under the covers. There's a very thin wrapper around that public REST API. And we even have things like client libraries for JavaScript and Swift to make the process of talking to the client library, the platform, much easier to do. So you don't need to manually construct the HTTP request. You just use the client library. And this works really well, right? You could do this from any mobile app. But it does require you to use your developer credentials, your cloud credentials that you have signed up for. And often when you're creating API endpoints, you want public API endpoints, right? You want people to be able to talk to them, the front end to be able to talk to them with no authentication. And OpenWhisk has two different ways to make this relatively easy. The first is by creating something we call a web action. So when you create your actions on the command line, there's a little flag you can set, --web. You can set this to true, defaults to false. And what that will do is the platform will then generate you a unique URL to be able to talk to on the platform that allows you to invoke your serverless function on demand, but it doesn't require any authentication. So again, you just kind of flip this switch and then you get a unique URL on the platform that allows you to invoke it programmatically with no authentication. And this is a really nice way if you just want to take your little serverless function and turn it into like a webhook endpoint or a chatbot endpoint, or just for testing and development, just kind of flip this switch and it's a proper public endpoint in the cloud. But if you're building kind of what I call big and more enterprise, like high traffic, big APIs for big customers, you're probably thinking about things like, what about like API routing? I want different cloud functions to handle different paths and different verbs and things like that. What about rate limiting? I don't want people just to call my functions too much, cost me too much money. And what about authentication? I want users to be able to have their own authentication credentials for backend services that they pass in. Like, how would you implement this kind of stuff, right? Using web actions and using serverless functions. And if you were going to use web actions directly for your endpoints, and you wanted to have some of these kind of features like routing and rate limiting, you have to kind of manually do it. You have to look at the headers coming in the requests. You have to manually work out how to do things like routing and rate limiting. And that's not a very sensible or scalable approach to have all this kind of replicated code in your request handlers. So the kind of strategy or the pattern that we use in the serverless community, if you want to build big public API endpoints with serverless functions, is you use cloud services called API gateways. So all big cloud providers have these kind of cloud services. They're called API gateways pretty much in most clouds. And what they allow you to do is they allow you to define big public endpoints on that cloud provider for your domain. and it will then proxy to your private APIs in the background. So it allows you to define public endpoints and then call private APIs in the background, and you can use these to create your endpoints for your serverless functions. And the great thing about API gateways is that all those features that I talked about, like API routing, like rate limiting, like authentication, like cores, these are just feature flags in your API gateway configuration. Say you can set up the routing and the core support and all that kind of stuff, and you don't need to worry about it in your business logic anymore. It just completely abstracts away from you having to worry about any of that kind of stuff, which is very, very nice. So let's do this, right? Let me take let's spend a couple more minutes and just take that Bitcoin function that I've got and testing and it's working and turn it into a fully managed API endpoint that I could really use in my application. So let me go back to my console now. Okay, so again, you can kind of do this stuff. Oh, I've got to mirror my screen. You can do this stuff from the command line, but I think for this little section, it just is a bit more intuitive if I show you through the kind of management console in IBM Cloud Functions. So let's start with that web action. Just want to flip the switch and turn it into an API endpoint that I can call programmatically. So if I go to my actions kind of overview panel, I should have an action now called Bitcoin. When it comes into London region, that's right. So if I go into the config for Bitcoin, I can go to the, it's going to show me the code, but I can go to the endpoint section. I just tick this box, right? I say, yep, enable as a web action, click save. And it's going to give me this URL down the bottom, right? So this is a unique URL for the platform for my function that I can call without any authentication. So I'll copy that URL and I'll go back to my console. And I have this little utility installed on my command line called HTTP, which is a really nice project for making HTTP requests from the command line. It's just a better version of curl, much better version of curl. Think of it like that. So I can use this. And I can say HTTP get. I give it the path to the web action. I'm going to pass the parameters just as query params. So say an amount equals like 10,000, and a currency equals US dollars. And it should just give me back the same. It should say like 10,000 US dollars is, I don't know, 1.58 Bitcoins or 1.57 Bitcoin, something like that. And you can see this is just a complete public API endpoint now that I can call my serverless function on demand. Just by kind of flipping that switch, I've really, really quickly enabled as a kind of API endpoint, which is really nice in testing or development, or if you just need something quick, not the kind of big enterprise, high traffic, that kind of stuff. But if I was really going to use this as an API endpoint for my mobile app, for my front-end application, I would want to use that proper managed API endpoint, right, using an API gateway. And OpenWhisk comes built in with an API gateway, so it's kind of part of that open source project, which is very, very nice. And again, you can do it from the command line, but I think it's much easier if I'd kind of do it graphically to configure it. So if I go back to the functions overview, you'll see that if I go to the overview panel, I have this little section down the bottom called APIs, which is the integration with the API gateway service. So what I can do is I can come in and I can say, create me a new API endpoint. So create me a Cloud Functions API. And now I can kind of do the config. So I can say, give it a name, call it Bitcoin. We'll give it a kind of API path, just call it API. And now I can do, because I'm using the API gateway, I can do the routing. I can say when someone calls a subpath Bitcoin with a get, call my action Bitcoin, return me some JSON, click create. And again, because I'm using API gateway, if you want to turn on, this is a nice thing about API gateways, if you want to turn on authentication or rate limiting or auth or cores, these are just feature flags. You don't need to have some kind of framework to manage it or some open source package or do it manually. It's all handled automatically for you by those platform services. So hopefully if I click save, it's going to give me, this time, a unique URL for the API gateway service that then when I call it, will talk to platform, will invoke my serverless function on demand. And hopefully this is going to work. And now I've had my own domain registered with the platform, then it would be my own domain. But since I don't, it's just giving me a route on the API gateway service. So I can click copy, and this should work exactly the same. It's just going to return the JSON from my function, but it's a completely different API endpoint. So HTTP get, we'll call API gateway /Bitcoin, and amount equals like 10,000, and currency equals US dollars. And hopefully it should just work, right? And what you'll probably see is that Bitcoin has changed in price. So even in the past 60 seconds, Bitcoin has changed in price. It is super volatile. But this is, again, this is a complete public endpoint. This is what you'd really use in your application. If I had my own domain, this would be my own domain at this point, which is really, really nice. So, hopefully, you can think, hopefully you can see at this point why, personally, I'm so excited about serverless cloud platforms. Like how easy it is to take some code from a laptop, to deploy it to the cloud, to get it working, then to expose it as a fully managed API endpoint in literally about 5 minutes worth of work once you've actually finished your code. And maybe now you agree with me, right, that servers kill your productivity. Are you ready to go back to the office and start setting fire to all your infrastructure? Right, but before you do that, it's only fair of me to also talk about some of the challenges of using serverless cloud platforms, because they're very new technologies, and like all technology choices, it comes with trade-offs and constraints and kind of downsides and just challenges, right? And serverless definitely has some of those. So I'm going to talk about 2 challenges that you might run into if you start to use these platforms to think about to see whether it is appropriate for you and your use case. The first is very Swift specific. The second is, or affects Swift more than other runtimes. The second is kind of generic regardless of what language you're using. Okay, so let's talk about the most Swift specific one. And that is understanding the difference between what we call warm versus cold activations and the effect this can have on the performance of your APIs. So what do I mean, right? What is this warm versus cold activations? Well, if you were really paying attention during the demo before, you might have noticed this behavior, right? The first time when I create a function, I invoke it, it's always a little bit slower than subsequent invocations, right? You know, as invoking it second, third time, it's always a little bit quicker. And this is not due to like bad Wi-Fi or some platform issue or noisy neighbors or things like that. This is an inherent characteristic of how serverless cloud platforms work. The first time you invoke a function, if you haven't invoked it for around 10 or 15 minutes, we call that a cold activation, cold invocation. Subsequently, it's called warm invocations if you invoke it very quickly subsequently. So why is this, right? Why is cold a little bit slower than warm? And to explain this, I'm going to drop beneath the covers and explain to you how serverless platforms work under the covers. Right, there are servers in there. I'm going to explain what happens when I actually start to invoke your function. So when you send that API request, right, or you use that CLI command, action invoke Bitcoin, that again then sends an API request over to that platform API, and a number of things have to be able to happen before you get the result, your JSON back from your code being executed. And on the left, these are the things that happen for what we call cold activations. Actually, under the covers, all serverless platforms pretty much use containers as your kind of runtime environment. So OpenWhisk has to find or start a container with a Swift runtime in. Then it has to inject your source code into the file system, because Swift is a compiled language, so it needs to run the Swift build to turn that into the binary. Then it can call the binary with the event parameters, call your function called main. Your code executes, does whatever your code does, and whatever you return from that function gets serialized back out to JSON, returned through the platform API. And all that stuff happens in milliseconds, right, to execute your code in the cloud. Now, a little trick that serverless cloud platforms use to improve performance is that once you've invoked it, right, and you have this kind of environment available, rather than just destroying it and then having to go through all of those steps again for the next invocation that happens within 5 or 10 minutes, what it does is it kind of pauses the container and puts it into a cache. So if you invoke it within the next 5 or 10 minutes for that particular function, it will just resume that environment because it already exists, doesn't need to inject your code into the environment because it's already there, doesn't need to run the Swift build because it's already been done. It can just call the binary again very, very quickly with the new input parameters, and whatever you return is kind of serialized back out as the response. And this is why there's a bit of a difference, and this affects Swift more than other runtimes, because Swift build is not known for being particularly fast, right? You know, things like JavaScript and Python that are evaluated, it's much, much quicker to do, but it does affect Swift more than other runtimes. So this is why there's a bit of a difference between what we call warm and cold starts. But the question to ask yourself is, number one, does this matter to you, right? If you're building like a webhook endpoint, or a message processing client endpoint, you probably don't really care whether it takes like half a second or 1 second or 3 seconds to process that event, right? It's not a kind of user-facing application. But if you are building kind of very latency-sensitive APIs, kind of user-focused APIs, maybe this is kind of really going to impact whether you can use these platforms. So if this is something that is concerning to you, I'm going to give you a kind of trick or a kind of strategy to manage this, to reduce the difference between warm and cold activations. And the trick is this, that rather than pushing your code into the platform, you can actually push the Swift binary. So you can run Swift build locally to generate the binary for your function. You can push that into the platform, and then what happens is during cold activations, once your package gets injected into the environment, it realizes as a binary, and it will just call it as if it's a warm environment. Doesn't have to run the Swift build much quicker. And this really narrows the difference between what we call warm versus cold activations. Like, they're never going to be exactly the same. And this is inherent in how serverless platforms work, because there's some extra steps to do. But the vast majority of the delay, the additional delay, is running things like Swift build. So if you're doing this in production for real, I would always recommend just running Swift build locally as part of your CI/CD and pushing up the binary, not pushing up the source code. But if you're just kind of playing around locally or testing, it doesn't really matter that much. So this particular characteristic affects, again, Swift more than other runtimes. The next challenge I'm going to talk about is very generic, right? It's going to affect you regardless of what language you use, and that is around compute limits, right? Compute limits, because serverless cloud platforms are very opinionated architecture. They're very opinionated platforms. They are opinionated about the kinds of applications they expect to run. It's for modern cloud-native microservices, which are scale horizontally and stateless and all those kind of buzzwords. It's not, you can't lift and shift legacy apps and try and then run them on serverless platforms, right? It just doesn't work. It's not designed for that. And so one of the ways that the platforms kind of, I think, enforce this architectural style on you is by limiting access to some of the compute resources you have available in the runtime. And again, it works the same across pretty much all serverless platforms. So these are some of the kind of limits for OpenWhisk, but I'm going to draw your attention to the two at the top that kind of might you run into and cause you some problems in the beginning, and that's around timeouts and memory, right? Timeouts and memory. So let's talk about timeouts. Right, when your serverless function gets invoked to process an event, process an API request, you have a maximum of 10 to 15 minutes, depending on your particular provider, to process that API request. Right, if you're still doing work after that time, the platform just kills off the process and returns an error code. And this is the same across all serverless platforms. They limit the amount of time those functions can run for. So if you've got some like batch job in your application, or that takes an hour to compute, and you can't split up the work and run it in parallel, like, it's not going to be appropriate for running on a serverless platform. It's something that can kind of catch people out. You have to make sure that you're within that time limit. And we call this a hard limit, because some of the limits with serverless, you can raise a ticket with your cloud provider and ask them to increase it. None of the providers at the moment allow you to increase the time limit. It's kind of fixed. It's for doing very fast request response style processing. And the second is around memory. So when I talked before about the charging model for serverless, I said you get charged for the duration, the amount of time your code is running. And that's true, but it's also multiplied by the amount of memory that it allocates. And you can change the maximum amount of memory a function has to improve performance, give it more memory, but also you take memory away, you make it lower, you save money essentially. So you can kind of vary the memory up and down. But the amount of memory that a serverless function can have available to it is in the low gigabyte range. It could be half a gig or 1 gig or 2 gigs, depending on your particular provider. It's not like terabytes of RAM. So again, if you've got some super high performance algorithm that needs like terabytes of RAM to optimize very quickly, you're probably not going to be able to run this on a serverless cloud platform. It's much more limited in the amount of capacity you can use. Same with access to things like dedicated hardware. If you need a GPU, things like that, you can't get any of that kind of stuff. It's for very kind of basic request response style processing, not really for high performance computing at the moment. So it's really important before you start using these platforms to just really understand the limits, right? Understand like what are the limits and how you can build your architecture to embrace them and not try and fight against them, because you won't win. Okay, so I said at the start of this talk, right, that servers kill your productivity, and maybe hopefully now you would agree with me, right? All that time, if you're getting into backend development, you have to spend like patching kernels and managing VMs and installing middleware and security and all that kind of stuff. I think it's kind of wasted time, right? It's not time listening to your customers on fixing business problems, on pushing out new updates. It's kind of wasted time where you just get held hostage by your infrastructure. You want to spend time in Swift and in Xcode writing Swift, you're going to spend increasing amounts being dragged back to some production issue running in the cloud. So I want to encourage everyone here today, right? If you're new to backend development, you're starting to get into building software in the cloud, think about embracing the serverless revolution, right? Burn your servers, deprovision your VMs, delete your containers, and be free forever from the tyranny of looking after infrastructure. But more importantly, upgrade your productivity, right? Spend your time getting back to actually writing code, writing Swift, and not on managing all of these sprawling VMs and all this sprawling infrastructure. So thank you very much. If you want any resources from this talk, probably take your phone out, take a picture of this slide. This has like a GitHub repo with all of the resources, everything I've gone through today. So yes, go to that and you can kind of run through all this stuff at home with OpenWhisk. If you like it and you think this is cool and you need some support, OpenWhisk has a very popular Slack channel as all open source projects. So come and hang out in there and we can talk to us in there, or ask on Stack Overflow and probably me will answer. Or if you need some kind of more personal advice or anything about this kind of stuff, feel free to @ me or @ OpenWhisk and we can kind of help you out. So thank you very much. Does anyone have any questions?